For number 12, they give you a Boolean expression and ask you when it'll always evaluate to being true. So since there are two ands here, you know that both of these things have to be true. So since there is the not on the outside, this actually has to evaluate to be false, because this will make it be true. So you know that this has to be false. So this actually means that A must be greater than B. And for this one, A times B has to be greater than 0, which means both A and B have to be positive. So since A is greater than B, B must be greater than 0. So the correct answer choice would be D. So for number 13, they give you a Boolean expression and they want a condition that guarantees that it's true. So you would go through the options for this one. So for A, it says that C is less than A is false. If this was false, the and would automatically become false. This whole statement would be false, but that would be good because the not is on the outside. So this whole thing would actually evaluate to be true. And since this is an or, one side is true, which means that it evaluates to true. So the right answer would be A. For number 14, they give you a code segment and they ask you which statement or what will happen if A is not equal to B. So since A equals B is false, that means that this part will evaluate to be true since the not is there, and since it's an and, you need this part to evaluate to be true as well. However, you're not given the n value, so you wouldn't know if this is greater than or less than 90. So you wouldn't be able to determine what happens on this side, so you wouldn't know if statement 1 or if statement 2 is evaluated. So the correct answer would be C. So for number 15, they're asking which statement is true about the following code segments. So for the first code segment, all it's doing is using a for loop and it's printing out all the values up till n. So if you plug in any number for n, it'll print out each value until then. And what number 2 is doing is essentially the same thing, but using a while loop. So you plug in your value for n, and count goes up till there, it uses increment over there, and it just prints out all the values. So the correct choice would be A, because they're doing the exact same thing for input value n. So for number 16, they're asking about the value int. And we haven't gone into depth about this, but they're determining the value of the integer value in the while loop. So that's too late because value is already determined to be 0 over here, so it won't end up equaling the final int. So the correct choice would be D, because the code will always process a value that is not on the list since it'll be 0. For number 17, you're asked to convert hexadecimal to binary. So what you'd want to do first is convert this to decimal, and to do that you would use the base 16, and then you would add up the multiplied values. So doing this, you would get 48 and 13, and when you add them up, you'd get 61. So to convert the decimal form into binary, you would write 61, and then 60 under it, and the difference is 1, and then you would split that in half. So you'd get 30, and then divide 2 into it, and you would get 30. So the remainder would be 0. Split that in half, and 14, get 1. And then you would split the 14 in half to get 7, and 6 is the greatest multiple of 2, so you get 1, and then you split that in half to get 3, then just 2 and 1, and when you split that in half, you get 1 and 0, because 2 can't go in it anymore, and the remainder would be 1. So this would be the reverse of your binary code. So you would go from here to there. So it would be 1, 1, 1, 1, 0, 1. So the answer choice would end up being A. For number 18, they're asking you to do something similar. You have to convert the binary to hexadecimal. So when you do that, 14 would end up being 0E, 20 would end up being 14, and 255 would end up being F. So you use the base 16 to convert it into its hexadecimal form, and by doing so, you would end up with this, which would be the answer choice C. For number 19, they're asking about which would represent the largest value that can be stored as a type int. So they tell you that an integer has 31 bits of storage. So that means it has 31 spaces for storage. If it just had one space, the maximum binary number would end up being 2 to the first minus 1. So since it has 31 spaces, it would end up being 2 to the 31 minus 1. And you would use the 2 because it's binary. So the answer choice that represents this is D. For number 20, they give you values for x and y. So x is greater than 5, so y would equal 3. And while x is greater than y is multiplied by 2, so y would actually end up being 6. And y mod x equals 1, but that's not true, so you would not do this one right now. And you would end up on the outside, and you subtract 3 from the x value to give you 7. So since it's 7, this while loop can still be ran because 7 is greater than 5. So your new y value is 6, and x is still greater than y since 7 is greater than 6. So you would multiply the y by 2 again and get 12. And 12 mod 7 is not equal to 1. So again, you wouldn't run this. And then your x value is 7, so you'd subtract 3 from that and get 4. 4 isn't greater than 5, so you wouldn't run this while loop anymore, and you would go directly to the system out print line. So your final value for x is 4, and your final value for y is 12, and that would be answer choice D. So number 21 gives a code, and the parameter for int n is that it has to be a 4-digit number. So basically what it's doing is checking each of the digits and seeing that if the first 3 digits mod by 7 gives a remainder of the last digit. So the first line of code gets the last digit of the number. That is the check digit, the one that it wants it to get the mod equal to. So last digit. So this one gets the remaining 3 digits. And then this one gets another last digit. This one gets the remaining 2 digits. This one gets the last digit again. And again, the remaining 1 digit. And then this gets that last digit. So at the end, they add up D1, D2, and D3. What that's doing is adding up the first 3 numbers of the original n, and then they mod it by 7, so they're getting the remainder of that by 7, and then they're checking if that's equal to the last digit. So when you go through all of the values, you get b as the answer, because 6 plus 1 plus 4, that equals 11. And then if you mod that by 7, you get 4, and the last digit of that is 4. So 4 would equal 4. So for 21, it goes off of the same code segment as the last one. It just asks what the purpose of local variable n remaining is. So n remaining is used to represent the 4-digit number as the numbers keep getting removed from the end. N remaining stands for number remaining, which refers to the number of digits left of the number. It allows the reader to understand what is happening in the code. So that's why the correct answer would be C, because it makes the code readable. It makes it almost like an algorithm. For number 23, they give you a code and want to get the outcome of it. So it's a nested for loop. The first integer equals 5, and then for 5, j equals I. So j also equals 5. And it does system out println 5 times j minus 1. So that would be 10 minus 1. First number would be 9. And since this doesn't have any brackets, the brackets are implied to be there. So the system out println is separate from this. So it would do the iterations of j equals 5 first. So j equals 5, and now j equals 4 because it's decrement. And 4 times 2 minus 1, that would be 7. Then it would go to 3. And from this you could tell the pattern that it's going in, because it would be the odd numbers going down to 1. After that, it would do the system out println, so it would go to the next line, and then I would end up being 4, because it's decrement as well. So that means j equals 4. So since j equals 4, it would have the same value as this. So eventually you figure out the pattern, it just moves down 1, and the code continues on like this until it reaches 1 at the end. That's when it terminates. So the correct answer for this would be B. For number 21, they ask which of the 3 codes will produce this given output. So to do this, we have to go through all the codes. So the first one has a nested for loop, and it has int I equals 1. And then inside is int k equals 1 as well. So then it says if k equals I, then print 2 times k. So they both equal 1, so you would print out 2 times k, which is 2. After this, you would go back to the k, and it would have a value of 2. So when it has a value of 2, it doesn't equal 1. So you would print out the dash. And you can assume that it won't equal 1 anymore because it's increments, so it's going to keep increasing. So then the next one, I equals 2, and k equals 1. So it would print out a dash, but then it would equal 2, so it would be 2 times k, so that would be 4. And then it wouldn't equal I again. So as you can see, the pattern will continue, and it will end up giving the output that it has up there. So number 1 would work. For number 2, they're essentially doing the same thing. They just have i's, and then I has to be equal to k, and if it does, then it prints out the number, and if it doesn't, it would print out dashes. So that's actually what they're doing for 2 and 3, because all of them end up working. So the answer would be E.